Hey everyone, I hope you all are doing great and having a great weekend this time. And today we are here on the 14th session of our School of AR series. And today we'll be learning about the body tracking. In the previous session, we learned about the hand tracking. It was really very mm, charming and fantastic filters which we created using the hand tracking feature of Sparkia Studio. And today let's learn from Naveen sir that how can we use the body tracking features and let's make some amazing filters out there. So without any delay, let's start with the session. Over to you, sir.
Hey, thank you so much, Varun. And hey, guys, welcome back to the final session of our journey. And I'm glad we have made it until here. And I welcome you all. And let's make most out of today's session. And the agenda is to learn about body tracking and also conversion between the coordinate systems between focal distance and the screen space, and will also convert the world coordinates into screen space and focal distance. So we're going to start with them, and we're going to wait for a while for everybody to join in. Meanwhile, if you have any questions, anything in Spark here, just paste them here. And I'm trying to share the resources for today's session, and you can get it from the same link that we always get it from. Hi, Shekhar. Hi, Aman. Hello, Harsh. Hi, Chintan. How are you guys doing? Well, if you have any questions, let me know. And meanwhile, I'm just and download this the unfinished project. Although we'll probably be working mostly from scratch in Spark here, but just in case if you want to go through those assets, and then you can download the unfinished project as well. Okay, I'm gonna share my screen to start with the body tracking if you don't have any questions. So we'll just we'll dive into body tracking today. Just gonna give it 2 more minutes. Yep, now the screen is shared, and I hope you can see the screen. Okay, now you can. All right. Today's session is about body tracking. Is one of the most exciting capability in Spark Air. Although there are a couple of things that we take care when we're using body tracking, because it doesn't support all kinds of devices. When we say body tracking is a lot of calculation. Body tracking is actually tracking the entire body and giving you some certain points which are being tracked. So we actually track 20 points in total in the entire body, and we segment those 20 points into six parts. The one is head, the second part is the neck, and third part is your hands, which are two hands, so third and fourth, right and left, and fifth and sixth is your legs. And each of them all combined give you 20 joints, and those 20 joints are helpful to identify which point is there and what is being tracked. So we'll identify all those points today, and we'll work with those points. And let me just bring in the body finder then. So hi Sarang, how are you? we're gonna start with the session now. We're actually talking about body tracking, so you haven't missed anything yet so far. Um, okay, this is very similar to. Let me also share the expectations from today's session, and then we'll start. Just trying to. Okay, this is a tattoo filter. This is body tracking tattoo filter, and there's a tattoo on my this tattoo on my neck, and there's a tattoo on my chest as well. And but there's no occlusion to it if my hands come over it. There is printed on my hand, but this is actually supposed to be a body tracking tattoo filter. So it tracks the points where the rectangle is supposed to be, and then it prints that puts that texture here. However, there is no occlusion that we can see. There's no occlusion. We could do something like that. We could try and make some occluders for it, but it's going to be a lot of like mathematic calculations, and I'm sure you're able to do that now. But this is how it is right now. There are three tattoos, I think four tattoos in total, three tattoos in total, and there's this cloth occluder, which has like a skin segmentation, I think. Is that how it works? So yeah, we use the skin segmentation for to work with the cloth segmentation. So what we do is we subtract the personal segmentation, and the person segmentation is the person. Um, so we can take a preview of this, but this is a person segmentation, and this is a skin segmentation, and we subtract those alphas, so we get the clothes, because from the person we subtracted the skin, then whatever is left is the clothes. So we do that, and that's how the cloth occluder material is working. So we can't see the tattoo beneath the clothes. All right, that's how it is working. um, Very simple project that it is, very simple setup also. We identify certain points on the body and assign the position of our rectangle to them. So this is what we're going to do. Similarly, that's what also we did um, into hand tracking as well. We identified some points on the hand that we want to put it on the center or the top or the left or the bottom, and we put a rectangle or a 3D object there, and we're going to learn how to do that with the 3D object today, because we're going to learn that conversion today. Okay, so this is a blank project. I'm going to start with the blank project. And hi, Sandesh, how are you? This blank project, there's nothing added to the blank project right now. So I'm going to go ahead into the patch editor and try to work with the body tracking patches. The first thing that I want to do is to find the body. To find the body, of course, it's a good idea to have a simulator video, like a full body, because for a half body it do track, but we want to check everything and it's working on the entire body. So we would need something like a simulation video, something like this lady. She's also not fully tracked, but maybe something like these guys, or something like this. It's like a full frame, so that we can test out what are we putting where. So I'm just gonna start with this girl for now, or keep myself up for the initial settings. And the first thing we want to do is find body. To find body, we use a patch called Body Finder. This is similar to how we were finding a hand. We were using a hand finder, and then now we are trying to find a body. So we will try to find the body using the Body Finder. Hello, Rai. You didn't miss much yet. We were just talking about the body tracking and comparing it with how we used to find the hand into hand tracker. And now we are finding a body into the body tracker. So there's a blank project, nothing added to it. We just added this patch by just selecting body finder. Right. Similar to hand tracker, hand finder, it gives you two outputs. Like if you find the hand, it gives you like, okay, how many hands do I find? All the hands that I find, and what is the count of those hands. All right. So this gives us two details, and similarly, the body finder gives us two details as well: the number of bodies which are present in the scene, and also the number of bodies that are there, the bodies and the number. All right, so this could have like the entire body as an object, and we could process this We could use certain points out of those. However, the second number is just a scalar number, just the count of the bodies. So we're going to go ahead. Similarly, in the hand tracking, after finding the hand, we wanted to select which hand, because there can be multiple hands in the scene, there can be multiple bodies in the scene. So we have to select one of them. So there's a body select patch as well. So we go and we select the body select patch, and we bring it into the patch editor. And now I see that the bodies has been identified whose index is 0. So that's this is the body that we can work with. Now from here, similar to hand tracking, so I'm gonna give you that analogy for the entire time, so that like something that you already understand and something that you're this is new to you. So you can make a reference like, okay, how the capabilities are so much similar, and like what's the difference is actually if you use body tracking, let's say for hands, because body tracking would also give you points on the hands. So what if you use body tracking for hands also and not hand tracking? So those things could be done. So I'm just going to give you that analogy in the middle. Hi Avinash, hello. Okay, so this body select, now we've selected the body. Now there are two ways to go from here. The number one way is, if you remember, for the hand, for the hand tracking, we had a bounding box, which was like rectangle, which gave us 5 points. Every bounding box is bound to give you at least at least 4 points. Fifth is the center, which is you can also calculate. But it's going to give you 5 points to the left corner, the right corner, the bottom, and the again left one again, and the center also. And those two other parameters like width and height that you can also calculate if you have these coordinates. So the body select, after selecting the body, I can go two ways from here. The number one is bounding body bounding box, and you can read the description. What are the other parameters are there? Nothing new in this. Only the center coordinate is not given to us. The center of the body is not given to us, and rest of the things are there. So we have the top left 2D coordinate, like where unless the maximum of my left where the body goes to the maximum of right my body goes, and same to the bottom of the rectangle. And so let's talk about the first way, and the other way is actually to go specifically to those 20 joints that we discussed about. That the body is going to give you 20 joints in terms of your head, neck, two hands, and two legs. So the body is divided into 6 sections. You can say six different patches that you can track. One is the entire head. Second one is the neck. Third and fourth is left and right hand. Fifth and sixth in the left and right leg. So this is the one way. Other way would be to directly use the head 2D patch. This head 2D patch is actually takes an input from the body. So we give that input from the body, and then we can access the chin, we can access the top head, the nose, the left eye, the right eye, the left ear, and the right ear. So 7 points here. So this sort of patch is going to give you access to the 7 joints that you can access. So we will come back to this one, but first try to use this patch. So what we want is that we want to have a rectangle or an object over my body when, and we want it to like resize as well. We want it to scale down as well, in terms of like, if my body, if I do this, then the rectangle should be smaller, but if I do like close my hands, then it should be bigger. So to do that, hi Irfan, you have missed nothing so far. We just included an empty project and a body finder and a body select. After selecting the body, we're using the body bounding box, and we're going to draw a rectangle around it. So I'm going to go ahead and find a rectangle for myself. When I add a rectangle directly, it automatically adds a canvas. And I'm going to give it a material, this rectangle to a material, something, some color. This is just body overlay. just call whatever you want. And this mat could be mat overlay. All right. Gonna put it flat, make it a little, make a little, I don't know, cyan color, or yeah, maybe whatever color. I just, I'm so picky sometimes. So you take that, and also we want this to overlay our body. So whatever comes behind this, we want it to be visible a little. So I'm going to put the blend mode to screen mode. So if you see that, then now I can see the lines behind it. And also I'm going to decrease down the opacity a little. Okay. Now I have this body overlay. I know the body points on my body. This, I know the left, I know the top, and the bottom. So if I if I just give the position to just one of the coordinates of the left of that, I can see that. Okay, I'm gonna go and bring on this. So maybe this rectangle that we have, this bounding box, we're talking about the bounding box. This bounding box, the maximum of the bounding box is the maximum the body is covering is this hand. So it's gonna draw a line from here, and this is the rectangle that the bounding box is drawing. Probably is gonna go below to the legs. But this is the left, top left 2D coordinates. That's where the body overlay. We gave the position, and that's where it started to a width and height that was already given to us. Like we gave it to 199, 100, 100. This is probably a bug that how it keeps adjusting it because we're not changing it. It's actually 100, but this is some sort of bug right now. So uh, we got that. Now we need to it to be equal to the size of our body. So what we're gonna do is we're gonna use the width and the height for this rectangle and use it from our bounding box because that knows our what is the width of the body overlay and what is the height of the overlay. And when that happens, I can see that now this my entire body is covered with that overlay because of the coordinates I given because of the I gave it to start from the top left. If I had given to start from the right, then it's probably gonna go into the right and I won't be able to see it. But if I also do this to bottom left, then it's gonna start from the bottom right there. You can see that it's gonna start from the bottom and it's from there it's going down and it's starting from there, the bottom left, and then it's drawing a rectangle which is equal to the height of the bounding box, which is actually equal to the width and the height of the entire body. So pretty simple thing to do is just to overlay things onto the body, and you can draw some things, you can make some things using it. You can use a personal segmentation and draw this rectangle behind the body. um, Use it for a couple of things that you might think are feasible into a body tracking effect. So pretty simple implementation of how to understand the body, these the body coordinates and the width and the height. So this is the one way to go about it. Now we're gonna go to the other way. So I'm gonna delete everything from the, or maybe just put it on the top. Now the other ways to go about it is use a particular patch that can give you a position of the joints of the body, joints in the head, joints in the neck, joints in the hands, and joints in the leg. So I'm gonna go with the head 2D. When I go head 2D, it's gonna give me 7 different points over my head. Right now, I'm gonna just delete this overlay, disable this overlay, it's visibility, and I'm gonna add a new canvas and call it like tracking points. It's good to have a like a tracking points where we can know like, okay, this is the elbow and this is different position. So gonna give another rectangle to it, and I'm gonna call it like new, and this material can be met tracking points. And when I put it on flat and just put it on red, and maybe I'm gonna make it a little smaller than this, maybe 25 and 25. Maybe I can make it to 40 and 40. All right. So this is like a small rectangle which can represent a point onto my body, over my body. So which point I want it to represent is, I'm going to give that position, and this is what on the chin I want it. So this is going to go to the chin, and this is not giving me any positions. So let me just try out again. Yeah, sometimes it happens that the body tracking project just stops working and doesn't give you these coordinates. So what you gotta do is just restart your project, and then it will be working fine. We're taking the body and when giving this coordinates to this guy, but it's not actually getting there. All right, so I'm gonna restart and take a new project. I hope this is working this time. So we want to have a rectangle, and this rectangle should be smaller, and a body finder patch which will give me body select. After selecting the body, I'm going to use that body to head 2D, and I can still not see these values in here. Okay, let's try to change a couple of things and see if that helps. So body tracking, we don't want on the Facebook, we just want on the Instagram. And just to make sure in the capabilities, everything is okay. 2D key points, body tracking. So we say, okay, okay, we don't want to use on Facebook anyway. So now we can see that those coordinates are coming. So it was a you go to the project edit properties, and you sometimes may have to enable that capability to like 2D key point tracking. And once you do, you will be able to use these points, right? So again, similarly, I'm going to create a new material, call it flat, put it math as tracking points, and put it on red. Also make it like 30 by 30. And now the position, I'm going to put it to the chin. And then you can see that it starts right where the chin is. So maybe too big for the chin, too big for to have like a tracking point. So I'm gonna just make it to 5 and 5, and then you can see that it's actually tracking the chin now. Similarly, I can do this for other joints as well. So all I have to do is duplicate this guy, put it to like, let's say, elbow, and elbow, which elbow, right elbow. So now I have to go to the one of the hands because that's what I want to track. So I go to the hand, and I go to the hand and to the all the body patches. They start with like 2D head, 2D neck, 2D left arm, 2D right arm, 2D. So I'm gonna go with the left arm, or yeah, I'm gonna go with the left arm, and assign this position right where it's supposed to be. So it is supposed to be on my elbow, and I can see that point is on my elbow now. So that's how you see that there's a little details that we're providing to a project. We are passing the coordinates of those tracking points to the scene objects that we are importing into a scene. So for an example, we imported these rectangles, and we assigned the positions to those rectangles. We assigned materials to those rectangles. Now this is a simple implementation. Let's try to do something. Let's try to open our unfinished project that I shared earlier. Everybody can just go to the link that maybe you might have it, you may not have it. Let me just give you if you don't have it.
Uh, Guys, let's wait for 1 second. I think there's some kind of technical glitch from our mentor. He'll be joining us back within some moments. If you guys have any kind of queries, please feel free to post it in the comment section. Or if you have any other, doubt or something you want to ask, you can please put that down in the comment section. He, he's just sharing the resources for the creation of AR filter. He'll be right back. I think the mentor is here back again. So yeah,
Hi, sorry
welcome
about
back.
that. Thank you. Sorry about that. I'm not sure why the StreamYard pushed me out of the account. Okay, we
No
can
problem.
share this link with everyone so that they can download the assets. Hi, Mohak. How are you?
Here goes the link. You all can
Uh,
access the link in the live chat,
Thanks,
and
Varun.
so
When you
you can
when you
share the screen and we can continue.
Yeah, thanks, Varun. You can go to this link and try looking for something is like a neck tattoo, and then you'll find a unfinished project right there. And again, share my screen. So this is our unfinished project where this lady has some tattoos. I think those tattoos will be better visible on here. So she's got few tattoos on her body, and then we can kind of assign new points for those tattoos as well. Um, I'm not sure why only one tattoo is visible. Okay, so there are a couple of things also that you should take care when you're using body tracking. When there are like multiple bodies, it's gonna be just so much confused which body to track. So we have to do those calculations. Okay, like if there are number of bodies, then we need to make sure that which body is getting which texture. So this one is I think when I open myself, I think then it's gonna show you a different one more maybe. Oh, it is just one tattoo. Okay, we just have one tattoo. Add more right now. So this unfinished project has nothing. So let's do the scene understanding first. How do we understand the scene is that we go to the scene first and we see that okay, there's a device, there's a focal distance, and inside focal distance there are a couple of elements that we have. So what are these elements? We have neck tattoo. This is one rectangle that we have already given to us. This is a face tracker that's just tracking the face and occluding the face. So it's almost like assigning your assigning your face object, your face texture to an object that is that being that face mesh. So the face occluder is actually occluding it. It's called occluder, but we're not actually occluding anything. We're just kind of um, printing a face texture on that. So this is probably to save a tattoo to come onto the face. So if I just go down a bit, it's gonna be like behind my face. So that's the only reason we are putting it here. The canvas has a neck tattoo in it. It's just a small rectangle that we can see that it's going to be situated on the neck, and there's nothing else. And so I come back to the patch editor and I see that there's a body finder. This body finder patch is selecting the body, and earlier we were doing the head 2D, so now we're doing the neck 2D. And neck 2D, which is this coordinate, that's where the tattoo is printing. And we said like, okay, we don't want the coordinate that you're giving us. We just want it a little bit up. So we subtracted some numbers from it, and then you can see that the position is changed accordingly. So let's say you want this tattoo to be right on the chest. So you may have to just offset it a bit. So you can use some subtraction and addition like this. And after that, they have unpacked it to X and Y just to smooth it out. Because if I directly connect this, that also works. If I directly connect this as a position, it's gonna be like super super laggy sometimes. Like it obviously it's tracking and everything, But sometimes it may be like flickering a little bit, like like tracking all the time, so it may flicker. So what we use is we use exponential smoothing to just make it better. And the only way to use exponential smoothing is on the single vector, because you can't use on the two vector altogether. So you have to separate them out, and after that you can just pack it back. After smoothing, you can just pack it back. So this is a useful thing that I'm gonna, I think, use again and again. So I'm gonna just assign this in here, and I see that this is something that is taking a vector 2. Okay, this is taking a vector 2 position, this unpack, and unpacking it, and then smoothing it out and pack it again. So this is something that I can use again and again. So I'm going to group it. I'm going to group it. Actually, let's start doing everything from scratch, so things are not jumbled up for you. So let's just start with a blank. There's nothing in this patch editor right now. It's super blank. So what I'm going to do is now I want to assign a tattoo to the neck. So there's a neck tattoo we have. There are a couple of textures. There's a right shoulder tattoo that we have. There's a neck shoulder, and there's a left shoulder tattoo that we have. So three tattoos, two on the shoulders and one on the neck. So we probably covering this area for the tattoos. So the neck tattoo, I already have this rectangle. I'm going to assign this somewhere. So first I need to have a body finder patch. Once I find the body, I need to select that body. So I selected that body. After that, I know that where I need to print this. So I'm going to just use a neck 2D. Neck 2D is going to give me a 2D position on the screen space. It's going to give me this canvas space coordinates for that. This is like maybe 200 something, 400 something, 300 something, 100 something, those coordinates. And that could be the position of my tattoo. And I see that as soon as I lock it here, this is actually coming right there. So this is half visible, half not visible right now. So what I'm going to do is I'm going to make it, I'm going to just push it a little up. So all you need to do is subtract number from it. So I subtract a vector 2 number, which is in X, maybe a little like 10. So now it's in the center a little, maybe 25 or maybe 40. So now it's like in the center a little. And I'm going to push it up as well. So 50 points, that's too much, maybe 25. Now I can see the tattoo is a little on the neck on the center. Later on, we'll also add the cloth simulation so that the cloth occlusion, so that it goes behind it, like when the cloth is covering it. Okay, the next thing now is to have it. This is okay. Now we wanted to smooth it out. We don't want so much of. Excuse me. Uh, so sorry about that. All right, so we want to have a little bit of smoothing into our position. So I'm going to unpack it, unpack to vector 2. Okay, so this vector 2 is X and Y, and I'm going to smoothen it out. So I'm going to use an exponential smoothing. Give it like maybe 200 or maybe 150. Use it again for the Y as well. And now I can pack it again. This is a vector 2 again. So after packing it, now I can assign this smoothen position to the neck tattoo. So now it's like a little smoothen. Now when I move, it moves a bit slower than my body. So maybe this is too much of exponential smoothing. So I'm just gonna keep it to like 80 or 80 because it doesn't really happen when you move your body, the tattoo moves with you. So it doesn't really happen that the tattoo is coming back. Like if you if you move, then the tattoo is actually flying to you. So so maybe a little less smoothing, but just to stop the flickering, we need to use a little bit of smoothing. Now I see that it takes some in 2D vector input and outputs a 2D vector input. So I'm going to just group it to a patch, and I'm going to call it vector to smoothing. All right. So now I see that just have a patch. Next time I have to smoothen something out, I can just pass to this patch and just use it like this. All right. So this is the first tattoo that we did. Now we have to do it on the right and the left. If you're doing it on your own right now, you're following it, try to do it as quickly as you can because now you have learned it. And meanwhile, I'm going to look for questions. Hi Kush. And to do this, this is like another rectangle that I want to add. And I'm going to call it just like the other one. I'm going to call it left shoulder tattoo, and duplicate this one and call it right shoulder tattoo. Right. I also want to have a material to these guys. So this material can be matte left shoulder and put it on flat. The texture could be the left shoulder. And similarly for the right one, I'm going to assign a new material, call it matte right SH and flat, and select the right shoulder tattoo for this. Now I see that both of the rectangles are there. All I need to do is assign their positions to the right points. So for this one, I'm going to use a left arm, and this left arm is going to give me this on the shoulder. So just directly I can assign this to the position of left and right. Of course, I need another right arm, and so obviously I can assign directly to this and assign directly to this, and it's going to show up right there. There's one tattoo here, there's one tattoo here, but this, of course, the cloth is, they need to go onto my skin, not onto my cloth. So first of all, I need to smoothen a bit. So I'm going to just copy this patch that we created and paste it again and pass it through this. So now it's like a little smoothen out. And similarly for this. If you want to adjust their positions, of course, you can add or subtract some positions. So I'm going to add some positions here. If I add some numbers like 20, it's actually going away. So I'm going to add minus 50. So it's going to come a little towards this side. Of course, this is a vector 2, so you can use a vector 2 number here. So in the y, it's okay for me. I just need to put in x minus 100. So I can see that now it's actually on my shoulder a little. And similarly, I can do this for my other patch, for my other position of this rectangle. And just maybe put it to positive 100 and 50, 75, 25, and that's it. So I have three tattoos situated onto three different positions right now, and that's the body tracking for you. Next thing I want to do is I want to have this cloth simulation. So in the same canvas, I'm going to use another uh, rectangle, and I'm going to call it cloth occluder. So also put it like 100%, 100%, and I'm gonna give it a material I'm just gonna call it flat matte cloth occluder. And its texture is, of course, my camera texture. Um, I need a segmentation. I need to exclude the person first, and then I need to I need to subtract this skin from the person. All right. So just to this cloth occluder has a camera texture to it, but of course this needs to be in the back, I guess. Hmm. And also no, can be in the bottom. And also that I another thing that I need from this is this. Okay, so right now I can't see them because this guy is on the top of everything. So it's actually hiding those tattoos. You can see in the back, it's actually hiding those tattoos. So we need to show them as well. So this occluder can have a camera texture, of course. So I'm gonna import that camera texture into the patch editor. All I did was created a consumer patch for the material of cloth occluder. So this is my texture, of course. Right now this is the setup. But I want to occlude this cloth, so I need to find the that alpha for this cloth. All right. So I'm gonna combine. I'm gonna bring back these segmentation textures into the scene, and just to be sure, we have a skin and person. So the number one is the person. Out of that, I'm gonna subtract segmentation of my skin of my skin. So this is the skin segmentation, the second one, and if I multiply these both, that should give me just the cloth. All right. So now I have the cloth over everything. All right. So you can see that the cloth is actually hiding those tattoos a little. All right. So that works well. Well, this is all about the body tracking, and oh yeah, of course, you could do some things like you can you can have multiple 3D objects as well. So this body tracking is actually 2D body tracking. We can't do a 3D body tracking where, let's say, we want to wear clothes and then put something on the hand, on the back of our body as well. So this body tracking is typically 2D body tracking, but in future the 3D body tracking is also on the way. So you'll have it soon. But for now, this get familiar with it, and you can do like I think a lot of things. You can make some filters where people are exercising, and you can make these counts like when, let's say, people raise their hands and then raise it down, raise their hands, raise down. So you can have those calculations where things are raising up and raising down. So you can make a workout filter, you can make a fitness filter, and then you can make people exercise using your filters. Like touch this point and touch that point. Like, let's say, if you're revolving. So I think that most use cases I can see for body exercise, for fitness, and yeah, this is pretty much it. I think if you have any questions in this understanding, let me know. Then I'm gonna just tell you how to actually. So right now, everything was there. I'm gonna wait for your questions. I want your questions. If I tell you everything, then you won't be able to understand. Like, so I think one of the questions that I would ask is that, like, why are you always having a 2D coordinate like that? What if I have a 3D plane? What if I have a 3D plane in here? So how do you handle that? So is if you already know, then you can answer me, but of course I'm going to answer that. But like, if you have any questions, just please feel free. If you understand everything, that's totally a good news for me. But if you don't, then I'm going to keep emphasizing and keep asking questions. So yeah, so right now, like, all we did was a 2D rectangle. There's a 2D rectangle. It's also a 2D rectangle. So it was okay for us to pass that position from these patches. Like these were giving us 2D position. So this was okay. This was fine for us to have that. But what if I have a plane? What if I have a plane in here? That, let's say if I have a plane, this plane, and This plane is a 3D plane. 3D plane. It is centered at 0 comma 0 comma 0, and it can go up and it can go down. It can, it can do certain things. So I know you've been waiting for those transitions between, um, between couple of coordinate systems. So I think today is the day when we do these things. So I'm just going to share my screen, another screen, so that you can have a look on how to, like, what is the reason behind the transformations that we do. So all right, so take please pay attention to this example right now. So what we have is a screen. This is our screen, and in this screen, this is part of my drawing. If I have a if I have anything that I add, like a 2D rectangle, the rectangle comes here, because this is 0 comma 0 for this. All right. And if I take a plane, the plane comes right in the center, because this is 0 comma 0 for this. All right. So when I have this rectangle, and then this rectangle actually goes from this position to, it actually goes from this position to this position in the maximum. So this is like about 375 units. And also this distance is about, let's say, 675. Obviously it depends on different devices, but let's say this, for example, this is that. So now I know that this rectangle, this 2D rectangle, can be represented at a point. It can be represented as, at this point, at this particular point, this can be represented as maybe 250 comma 10, or 250 comma 50. This point could be that. But if I do the same thing for this plane, the 250 is gonna, I don't know where it's gonna go. Is if I 250 in x, will, I don't know where would that be, somewhere into the very far from that. So we can't use the same coordinates. So we need that conversion in here. Another thing to notice is that, so this plane that you see at 0 comma 0, this is the plane that 0 comma 0 right now, and this is the maximum that it can go. So this entire distance is 1. So this distance is 0.5, and this distance is also 0.5. However, also this distance that we have is also 1 unit, and right now it is at the center. So this center is also 0.5, and this distance is also 0.5. Okay, so we will come back to this. We'll come back to this. Just to recap, don't be overwhelmed with so much maths. It's just that we need to understand this coordinate system, that this is 0 comma 0, then this is the positive x for this, and this is the positive y for this, because that's how it's moving. But for this one, everything is different. For this one, this is positive y and this is positive x. So x is positive for both of them, but the y is actually in the opposite direction. So we'll make these changes. So first of all, thing to note is that positive and negative y. The second thing to note is that the distance 1, the unit is 1 for this one, and the other one has units from some width to some height. All right, so we'll come back to this conversion. So what if how do I make them in the same position? How do I make this guy at the same position? So what I need to do is I need to shift this by this distance, and then I need to shift this by this distance. So I need to take it here. So we'll do that now. Hey Rai, we will also come to the world object as well. But right now, let's focus on the screen first and the focal. Once we know this conversion, the world is very simple. All right, so I have this plane which is at 0 comma 0 comma 0, and while this neck tattoo is like, some 100 and something like that. So if I give this plane like, 5 point, this is gonna go so much away into the x direction that I can't even see it. It's so far. It's so much far, you can see that. So need to convert that. So the one way to do it is that, very simple concept, that we want to convert something to a distance, to a coordinate system. We want to convert a coordinate system to another coordinate system. Then what if I make things children of the main 2D object? So if I have this canvas is a 2D space, is a this canvas space. So what if I put this plane into this canvas? What just happened? Okay, it just became so big. It just became so big because when I put it here, you can see the scale just became like super impossible. Like, I don't know what is that. So I think all we need to do is make it to 1334, 1334, 1334, and 1334. Then you'll have it like the actual size that you have. Oh, okay. The position is also like some 8,000 something. So now I can see that I have that. I'm gonna remove this cloth simulator for now, and also everything on the top. Don't have to remove them. Just have to remove this face tracker. All right. So this is now actually, this plane is a part of canvas now. Okay, because it has been shifted to the 2D canvas. So it's a scale where it was 111. Now in that 2D coordinate system, the 111 is nothing. So what we do is we multiply it by 1334. This is the, I think, by default canvas size of the maximum y, and we're going to use this number a lot into our conversions. So 1334, 1334, 1334, when we do that, this is actually considered as scale one. So, and a good thing when you work like this, what you do is you take it out into the patch editor and create a value like this, like create a value which is a vector 3. And now you can just put like 1334, 1334, 1334, 1334, and just multiply it with a number that can be your scale now. So now if I want to change the scale, I can use this number to change the scale. Instead of doing those calculations like 1334 multiplied by some number and some number, instead I can use this one number and use that scale. So this is my first step to the conversion, that I put that to inside a canvas. So I put a 3D object inside a 2D object. So it became a children of it, right? So it has to follow the position of that canvas, it has to follow the scale of that canvas, it has to follow all the transformations of that canvas. So this is done. Now another thing that I should do, like right now, like I know that it is still in the center, like the position hasn't changed, it is still the center. We want this at the top of this, like at this coordinate. So let's say if I want to assign it to my, if I want to take it there, so what I need to do is I need to subtract this length. All right, that's what we understood in the diagram that we just made. So I need to subtract this distance, and I also need to subtract this distance. So to do that, I need to know that distance first. So I'm gonna use a sorry, I'm gonna use a screen size. So I'm gonna divide it by the scale. This is my resolution. So this resolution's midpoint will be, if I divide it by 2, all right, then that would be the center of it. And if I subtract it now, if I subtract the position of it now, So this is my center point. So I'm just gonna call it center and call it like center point. Okay, so my center point. Now, wherever the position of now this is the plane, and I'm gonna bring that position in here. So let's say I want to work with, I want to put this on the neck. Okay, so I'm just gonna bring another neck 2D. Okay, and this neck 2D it give me the canvas position, so I need canvas position to pass this guy. If I directly pass this, it's not going to work because right now the positions are as not so well configured because we haven't subtracted it. So you see that it's a little bit up from, it is tracking, but it is not at the right position. So we have to subtract that difference that we have got it from here. So I'm going to subtract it from here and from the original position of it. So subtract the center of it, we subtract it, and then we get this point. Now I see that it is supposed to be on the neck, and if I'm moving up, it is coming down, and if you're moving down, it is going up. But it is okay in the X. And do you know why is that? So let me go back to the drawing that we were doing a little while ago. And you notice that in here it was the positive X was this was the positive X. This was the positive X for the rectangle, for a 2D rectangle, and this was the positive X. So they had the similar vectors, similar direction vectors, but for Y it was opposite. This was positive for this, and this was positive for this. So that is why we have to multiply it by -1, and that means we have to just multiply Y by the -1. So I'm gonna have a multiplication here, and just multiply, okay, 2y by -1. And then as soon as I do that, you will see that now it tracks the neck. Now it tracks the neck very well. So I did this to very simple plane. Let's import a 3D sphere from higher sphere. So we imported a 3D sphere, and I'm going to put this 3D sphere to the canvas, inside the canvas now. And I see that the sphere is right there in the center. Is it part of the canvas? It is part of the canvas. Does it get some positions by default? Yes, it gets the position by default, but I don't like those positions. I don't like those scales, so I need to fix that. I need to get the scale from this guy here. This is the correct scale. However, the position is at 0, 0, 0, so it's not changed. If I want to have that position on the neck, all I need to do is connect it on this point. So I can see that now the 3D object is still being tracked to that position of of um, of that particular neck point. Do we understand this conversion? Is there any doubt in understanding the maths, in understanding any steps? Like why did I do it, and why is that happening? Because it's a good time to tell me now, because later on we're going to do some complex things, not the complex things, but we're going to move ahead, we're going to build upon this. So I've already addressed this. We're going to talk about the world transforms in a while. So after converting the screen space in the focal coordinates, the canvas space in the focal coordinates, we'll also work with that. All right, Shekhar, that's good to know. That's clear. I think it's nothing rocket science. It's just don't be worried about the drawing. Maybe just it's okay. But still, if you need to understand anything like a 3D object was working fine. Like right now, we're also having a 3D object and we're also having a 2D object, but all are working in the same coordinate system right now because of the conversion that we did. Although what we can do is this is the conversion, this is the entire conversion that did. So we can just group it like a like make it a patch. So we can call it like a convert 2D to canvas, convert 2D to canvas maybe. So that's, and ideally this change is there's not much change in here. The only change is is that we're passing the center point. So we're not actually converting. Conversion will do it. Right now we're just offsetting. Right now we just set it to a different position to be at the right place, because the conversion is done by this canvas here. This is the main thing. When I made it a children of this guy, everything just gone into that space. All right, but this is not the exact thing that we're looking for. We will convert it further. So this is the main. I think I'm done with the body tracking, and if you're clear with this, then we can move ahead for the conversion of other points and focal distance and the screen space and the world transforms. So yeah, this is it. This is it. Any, if it is clear, then pretty good. All right, I'm gonna start with a blank project. Just a moment. I have, okay. It's a blank project, and let's try to convert a 2D position to a 2D position to a 3D position. All right. That means my input. I'm just drawing it out. That means my input should be like a vector two, and then input should be like a position on a 2D canvas. Let's say 100 by 135, 134. This position needs to be passed to a 3D plane. So let's say that's a plane. All right. So this plane has a position like point 1, point 2, point 3, like in that manner. So I need to convert this to this guy. So how do I do that? So this conversion is what we're gonna do. So I'm gonna come back to my drawing and draw a new one this time. So it's easier to understand. Okay. All right. Um, Take an example of we'll make two rectangles this time. Both rectangles are exactly the same, but just pardon pardon my drawing. And this one is a plane, like this one is a plane, and this is like focal plane, and this is a canvas. All right, this is canvas space. So in here, this distance is 375, and this distance is 667. I'm just taking a example of, let's say this is iPhone 8 or something like, so both are iPhone 8, and this distance is 1, and this distance is also 1, right? However, my canvas starting point is this one, and my plane starting point is this one. Okay, I need to place this guy in here first. Once it comes here, then I need to shift it in here. So I need to take this at this point, and this is, I don't have to move, because to make them comparable, to make this conversion go, I first need to have them onto the same position. Once I do have them into the same position, after that I can make I can make the displacement. Let's say if I move it by 10 points, then I can move it by 1 divided by 375 into 10 points. That will give me like a like a number that this plane should move. Because I if I move this by 10, this is gonna go I don't know where. So I need to have that multiplication to get that position in here. So yeah, this is the point. So we will try to cover this one distance by the entire space in X, and also this one distance by the entire space in Y. All right. So this is the whole idea behind the conversion that we're going to do now. So I know my my input, and I need to have an output to this. So just to convert it, what do I need? I need to first shift it. I need to shift it to a point. So I need a subtraction. And again, I also want to have my camera so that I can have those 2 points. This is the screen size. So I'm going to create a sender for this screen size. And then I'm going to have a screen scale center. Although we're not going to use this screen scale center, but still we can find the resolution by like this. So this is my screen resolution. Resolution is always the total screen size divided by the scale, right? And now I'm gonna just keep it to there and maybe make it a little bigger so that we see more space in here. Okay, so I need to find after dividing this, I have the screen resolution. If I divide it by two, again, if I divide it by two, I will have the center coordinates. I will have the center coordinates. So this is, and let me also put it to iPhone SE. So we'll have the similar numbers that we were using in our example while we were drawing it. So if I divide it by two, this is my center coordinate. So I'm going to call a sender, and this is my center coordinate. So the first thing that I want to do is subtract it, subtract the center from that. So if I do this subtraction, it's going to give me subtracted output. And after that, like, I'm going to keep it to 0 0 for now, so that I understand that, okay, what is my center? My center is at 375, 187 and 337, because this is 375 in total, so 175 and 675, so 336, whatever, 667, I think. So this is the center right now. So I shifted that, I subtracted it. After the subtraction, I see some points like minus 185 and that. So I need to divide it now. I need to divide it by the maximum number that it can go, the maximum y that it can go. Because for the plane, the x is also y. For the plane, the x is also 1 and y is also 1. So we have to take the aspect ratio into account. It is not a perfect square or like a perfect rectangle. So we need to have that aspect ratio into account. So this is the maximum size of the screen. So I'm going to swizzle it to y. Swizzle it to y, and this just divide it. After dividing it, I'll get the points number in points. I'm sorry about that. All right, so I'll get those numbers into the points, and I'll just have to pack it to a 3 vector. So this is a 2 vector that I'm getting from it, like 2 numbers from it, and I added the z as 0, and I'm just gonna give it. So you see that it goes like right into the corner of the screen, like it goes into the screen of this. And if it goes here, that why is that happening? Because of that, because of the y for this one is now down and y for this one is up. So we need to multiply it by -1. Just need to multiply the y, not the x, by -1. And now you see that now we are at the same position. The only difference, there's one difference yet so far. If I use a canvas, if I use a rectangle, the rectangle starts from 0 comma 0 comma 0. Okay, starts from 0 comma 0. So this is this is 0 comma 0. All right, and that's where it is starting. But our plane that we shifted, that we converted, is actually starting from the center, because that's how the plane was place was initially there. It was counting from the center. So we're almost there. We're almost there. We just need to subtract. We need to take this account, the center, and need to subtract it. So I'm gonna just call this plane as a plane. It's already plane, and this rectangle. So I'm gonna give them different colors. So this is a material. I'm gonna call it to flat and make it a little blue. And this rectangle, I'm gonna make it well, yellow. All right. So our expectation is the yellow one, but what we have right now um, is the blue one. So just to keep it on the top so that you can see both of them. So my expectation is actually slightly different from what I want. All right. My expectation um, is the yellow plane that I want, but my blue plane is a little bit shifted into the, like center is the 0 comma 0. My center should not be the 0 comma 0. That's what I want to change. So just like, let's make this a little tidy and neat and clean. So this was the sender. We took out a lot of information and used only just the center and the resolution in terms of y coordinate. And so I can just keep it aside. Okay, this is this control unit for me, like centers. I call them control unit, keep them aside. So later on, if I have to modify something, I just modify it in here, and that can just work out into the entire project. And right now we are at 0 comma 0. So we can check if this is working or not. So I can put like, hey, 20 and 20. So that's moving. But I also give this position to this rectangle so that we can have the position expectation for this also. So now if I do this 20, I can see that everything is moving well. Like in 250 and 50, I can see that that's moving well as well. Of course, the size of the plane is something that maybe we have to take care of. But for now, the center is different. So 0 comma 0. The How do we know that it is the center? Because it is actually we can see the center, and then rest of the things is not visible for us. Again, to understand the this one, all we did is that took the original coordinates. We took the original coordinates, subtracted the center from it so that it came here. After that, we divided it by the maximum y resolution, so that that one could be divided proportionally. And after that, we multiplied by -1 and just packed it back. So this is my entire calculation that I wanted to have. Now, another thing that I wanted to be the center of the center to change, then I need to use the bounding box. Okay, so bounding box gives us the information of what is the length of the plane and what is the length of the object that you're working with. So I'm going to use this and call a normal bounding box. When I look for bounding box, you'll see like a couple of bounding boxes. There are like the simple bounding box. This is body bounding box that we use today. This is hand bounding box that we used in I think one of the session for hand tracking, and this is the bounding box 2D unpack. All of them just gives you coordinates of the left and right and top and the bottom, and it's the same thing. Like, so I'm gonna use this body bounding box. This body bounding box can be, you can apply any object's producer patch to this and get its length and get the points around it. Okay, while the body one and the hand one, they specifically want the body and the hand inputs. Okay, so this one, um, I can see that this this is gonna draw a rectangle onto this plane, and this is gonna draw on the front and on the back also. So that gives you like very much flexibility in terms of if you want to work with it. So there is something in the front and there's something in the bottom as well. So if I'm here, And if I want to go there, then what I want to do is, if I subtract this thing from this, if I subtract this, if I get this point, what I have to do is I add both of these and divide it by 2. I'll get this point. All right. If I similarly do this to this as well, the y as well, then I get the I will get this distance. I will get this point. So what I'm gonna do is I'm gonna take the top front. Where's the front? Bottom left front, bottom. No, I'm gonna just take the top right, left front, and the right front. Okay. I can take any two coordinates because this is a plane, right? I can take any two coordinates. So I'm gonna use the front one. So maybe the top left front. Yeah. So I'm gonna subtract this from this, and the no, the top, just a minute. Top left front and top right front. Top left front and top right front is not going to give me anything. Like it's going to give me just one coordinate. So what if I take this coordinate and I also take this coordinate, and if I divide and add both of these, I'll get this line. All right. So it's better to have a top right front and have a top bottom right front. All right. So this is going to give me bottom right front, right front. So we now need a left front. So this is going to give me both the differences. Don't worry about it, like a little bit mathematics calculation. Even I'm not sure I'm doing it right. I'm just doing it right now because this can depend on your project, that if you want the center right here or not, or you can always shift it a little like that. But when we're learning things, let's learn the best way. So this is a point that we can subtract. So I have to like divide it by 2. After subtraction, do I have to divide it by 2? Let's just figure out. And and I'm gonna add it in here. This is vector 2. This is vector 2. Has to be vector 2. Oh, we can't edit. This is strange. I just added it. Okay. So I think unpack. Okay, let's redo this. So what we want is we want to have this coordinate and this coordinate, and if I need the distance of this, if I need this distance, if I'm gonna shift by this distance. So let's do it in one by one. Let's do it in the x coordinate first. So I'm gonna take the no, top right front, the bottom right front is this one. I'm going to take the bottom right front and unpack it. When I unpack it, it's going to give me x and y. And if I do the same for this was bottom right front, right? And I'm going to go to the top left front, all right? So I'm going to unpack it. And this is also vector 2. And I'm going to subtract the x from x. Take the distance from x, and take the distance again from y, and this distance is my coordinate now. But let's try to okay, gives me something for sure. Okay, so I need to shift it. So I'll probably have to add it. That's okay. Um, it's not did into x, so we did it a lot. So that means the distance, and we added it. So we need to subtract it, I think. Oh, this distance has to be divided by two, I guess. It has to be divided by two because that's the entire distance that we're talking about. So maybe all we can do is just divide it by two, and that should fix our problems in the universe. Yeah, it fixed our problems into the x for sure, because now our y is come down, but our x hasn't come down. Don't worry, I'll just repeat these steps for you. But just wait for a while. We took that x and x distance and the y and the y distance, and that's how you're coming down, of course. But this one needs to be okay. Let's just take the y for once, and we will shift to the. Okay, what are we dealing with here? This is bottom right front. Okay, so stop right back, bottom left back. Like okay. Stop right front. No, it's okay. So now we have this distance, and if I pass it in here, okay. I think the we also have to multiply it by -1 in the y. Okay, so this is a little bit of mix up between the logics that we're trying to find for to shift it to shift it down, and even if you don't do this, that works well. But we'll try to figure this out first. So so let me just try to understand this. Right now we are at the center, so if we want to shift this by x of this length, so what is this length in total? If I subtract the top, give me the top front back. What is the top front back? This is the top front back. And if I take the top front right, okay, top front right, and I also want the top front left. So with the top front left, this is top left front, okay, and this is the right. So if I subtract the x top right to the left, I'll get the total distance. How far is it? And then I divide it by 2. Then I get the distance of that distance, and then I need to add it to the that. So this is okay. The x is working fine. The x is totally okay. About the y, my y is top left y that I know, and if I take this y and if I take this y, this is going to be no change, of course. This is going to be no change, of course. So I don't need this. I don't need this y. Y is not taking from this one. We would have taken any other one, but for the y we will take the front. We'll take the top left front, and we'll take the bottom left front also. The bottom left, the top left front, or the top, you can take any actually, right front. So you just unpack to vector 2 and get the distance between these two. This is the y, and that's how I'm going to pack it. And of course, it needs to either you multiply it by minus 2 or subtract it. All right. Now we have it. Now we finally have it. All we were doing is we were trying to just minimize a step, and we kind of got here and there on the way. So we used the bounding box. We calculated the distance. Okay, so this box was centered right here. So that's why the center 0 comma 0 was representing it, and the sum of the part was actually going away from our rectangle, the screen space. So what we did is we subtracted that distance into x and the y. We calculated that distance and we added that distance. Sorry, we added that distance and shifted it to so that the 0 comma 0 actually becomes this point. So I think this is going to work on every scenario, all the scenarios, whatever 3D object or 2D object you're going to put in here, it's just going to work. So for the conversion, I would say my patch would become like this. This is the center. So I'm gonna group it. This is the group. I'm gonna group this guys together, and this group is I'm going to call it to, what are we doing? We are doing canvas to focal plane. So this patch is going to always work for me if I use this any coordinate that I want to use. So all right, so if I have to convert, all I need the inputs that I want to convert, and I'll get the output if I pass this to this patch. You may or may not need this. This is just to, if you want to care about that center, then you can remove it or you can put it as well. It's up to you. It's up to you. So let's try to make a loop animation and see that is it working okay on all the boundaries. So I'm going to take a loop animation, and this loop animation, I'm going to make a transition for it, and this transition should be from from a vector to from a vector could be vector 2. All right, so from 0 to, in the y, I want to go for like 375. That means this will completely go until the end of this, and we won't be able to see it, and this will be 0. So let's see this if this is working. Yep, we won't be able to see after this point. So both of the rectangles are actually moving, that this is moving as well, and this is also moving. So yeah, good that we worked it out. Now we have that exact position, and now we have that conversion ready. Very simple task. All you have to do is use this canvas, the patch that I created just now. All you need is center input and the screen size inputs. Actually, you just need a screen size input. Center is actually being calculated inside only, so that actually doesn't matter. But just to understand, you can club it together, change the group properties, name it something else, because you're going to use this quite often. So save this patch as something that you can go back to. Or tell me if there is any doubt in this particular concept. If not, then we're going to move to the next one. A simple math. Maybe a little overwhelming sometimes. If I don't practice this, also I get confused, especially on a Sunday evening. So yeah, so I think simple concepts. This bounding box is useful sometimes. I don't think I've used it a lot, bounding boxes, but sometimes they're useful to calculate these numbers and these values. But this is it. This is, if you go inside this patch, this is the conversion. Like the point that you want to subtract the center and then divide it by the maximum of your y, and then multiply it by the negative number into the y, and then add it if any offset that you want to add to this. So my offset was like 0.05 into the, yeah, in total it was 0.05. I could have just directly put it, but but that math is going to work for any kind of plane that you put, any kind of object that you're going to put. So yep, so simple, we got it, we got it working. Any questions? If it is clear, then also tell me it's clear, and then I can move ahead. So remember what we did was canvas to focal plane. We can also do the opposite now. So maybe that's something that you can do. Yeah, a bit confusing because of this box. So I'm sorry about that because I got a little confused between these bottom left and stuff. But this should be clear. I think this is the main concept. Don't worry about the bounding box. Actually, don't worry about it. Like, don't really worry about it. You don't have to give it here. It doesn't matter if that plane was 0 comma 0, because we can always shift it. We can always have those offset values that we can give by ourselves, right? But just in case you want to handle everything by the code, then that's the way that we should know the proper way, and then we should know the hacks and everything. We can always do them, but the proper way, we should learn the proper way first, and then we can go anywhere from there. So if this is clear, then we can move to the next point. I think that's going to be like super interesting for you guys, because of I think it is interesting. So I'm going to save it so that I can share this later. Mm, right. Okay, so this is that pretty well done. I am glad that you guys understood this. So I'm just gonna keep it to disable this guy, disable this guy as well. So our project is completely blank. Um, just in case if you want to go through these, I'm just gonna group it, um, comment around, and I'm gonna call it to canvas to focal conversion. All right, so now we're gonna do the other one, which is a world position to focal plane, world position to canvas plane. One and the thing, same thing. Like if we can come from world position to canvas, if we can come from world position to canvas, then we can go from canvas to the plane. And if we can come from world position to the plane, then we can go from plane to the canvas, right? Because the canvas and the plane are interchangeably. We can do this now. Like now I think this is very simple thing to you to do, to figure out like what if I have this input and I want this output. So that is something that you can do now. Like maybe somewhere there was multiplication, now we'll have to divide it, and then like you have to trace it back. So that's all your homework, to convert this to like focal to canvas. So canvas to focal, focal to canvas, canvas to focal. But we're going to talk about the world position now. World position can be anything. It can be your face tracker, it can be your hand tracker, it can be a position in the world, it can be anywhere. Like those are actually world positions that we talk about. So let's import a face tracker. Face tracker. This face tracker has an element called null object. We can call it null object. Let's call it nose. This is the nose that I'm referring to, and the position of this nose is like I'm gonna give it a plane also, of course. No, don't give a plane. The position of this nose, this null object, is somewhere in the. Oh, I have no idea why this face tracker is actually situated on the camera. That shouldn't be right. So I need to delete it again. I think this is the children of the canvas. So in the focal distance, I'm going to add a face tracker. Yeah, now it's okay. So this face tracker has a null object. I'm going to track the nose position. So what we're going to do is that every time we have something on our nose or our face, that actually visible on the screen, but actually that is also in 3D. So what if I'm playing a game and like, I want my nose to collide with it. So to mark that collision, I need to make them on like a same plane first, and then I can collide. So to do that, let's figure out how to do that. So I'm going to use a null object and I'm going to call it nose. So this is the nose position that I'm going to give. So this nose position is the position of this nose is actually a position on the face. All right. So I just brought back the face tracker and the face, and I'm gonna take the nose and take the nose tip. So if take the nose tip, so that means that this guy is actually on the nose tip right now. So I can add something here like a plane, and I can see that this is on the nose tip. Okay, so I'm gonna delete this plane because we don't want anything on the face tracker. We want something on the plane because we're converting this position to the plane. So I'm going to keep it as a face tracker plane. All right, this this plane because I'm not going to use it just to representation. Um, Actually, this is the expectation. So the expectation is the yellow. Like this is the reference for us. I'm also going to make it to like zero point 0.5 and zero point 0.5 and zero point 0.5. All right. So this is a point which is in the face tracker and it is at the nose. I want a point corresponding to this on my screen plane. Like if it is here, then if I'm moving, then that's moving in x and y, but moving in z doesn't affect it. So I need a mechanism like that. So simple stuff. If you understand the concept already, you would be able to understand this. Like how do I do this? So what I need to do is I need to take the position of this nose, all right, because this is the position that I wanna change. So I created a producer patch for this, and I'm gonna use a global transform on this, all right, because this is the I need to have the position of this in the global space, and once I have this position, I can see that there's a position that I can get from here. So this position, then I'm gonna take something on the plane, something on the plane, like a focal plane. This is my focal plane, and this focal plane has this material, and also has the size to like point 0.2, point 0.2, and point 0.2. Right now, it's not tracking. It's nothing. It's not. Doesn't have any position. And if I give this position to this guy, this plane, uh, you'll see that it kind of disappeared. It's kind of goes away into some other direction. I, yeah, it's the global position of this that it's not something that I want. I want to have it in the screen plane. So, so I'm going to take this um, position vector. Of course, this is so I'm going to unpack it. I'm going to unpack it to let's unpack it first, and we will see this. Okay. And I don't want to consider the z because the x and the y for this and the x and the y for the other plane, they're going to be the almost same, like because if this is x, then probably its projection on the screen will be the same. Also in the y would also be the same. There would be a little bit factor of the z, but we'll take care of that. So this one, I think if I just take the x and the y and pass it to this guy, would it be still the crazy? Yeah, still crazy, still crazy. Okay. So it's it's not part of the face tracker. So right now its position, the global transform is actually giving me a position that is not reflecting now. Okay, so I think we've done it right. We've done it right. This plane is position, and if I don't use the Z, okay. Yeah, I think we're missing that Z. So if I change the Z, it does work. Like, hmm. Okay. So first of all, we need to take the consideration of the Z. That means I need to calculate the focal distance. The focal distance is a distance. So right now this is on the focal distance, but the X and Y is like super far away. Um, so we need to take care of this distance. The focal distance is the distance from the camera where everything is being projected. So to calculate focal distance, all you have to do is maybe create a, although these lights are always in the part of the camera, so you can use one of the lights, but just to use the we can just create a null object in the focal distance, so we're going to calculate the distance from the camera to the focal distance. So anything which is in the focal distance, so we'll take that null object just to calculate the focal distance. All right. So this focal distance, I need to find this distance from my camera. So I'm gonna use a camera distance patch. Camera distance patch. This is gonna give me that distance. And if I divide this distance, because I need that proportion. So if I divide this distance by this number, then I'm gonna get to a promising number. Yeah, the only problem is that it's moving. It's way into the Z direction. So we're doing everything okay. I mean, just give me a moment to sort this out. Well, meanwhile, feel free to ask any questions if you have, and let me know. I can help on something. I think we're doing okay. We're kind of missing some steps. So of course we don't want anything into the Z because we want to keep that plane onto the screen space. So this has to be zero. This has to be nothing but zero. But we want to modify our X and Y's based on that distance. So we're gonna multiply this here. We're going to multiply this difference, and that's going to be a new position. So now I can see that now I'm back to the focal plane, and I can see that it's moving into the opposite direction, and that's what was happening earlier. So if it is moving in the opposite direction, if I move into the Y, that's fine. But into the X, it is moving into the opposite direction. That's probably because how we're looking at it, all right, from the world transform. So I'm just going to multiply it. Just going to multiply it with a number that can make sense to us. Like if X is going into the opposite direction, then just -1 into the X. So, and Y is 1, okay, and then yeah, this is a global transform. This is X and Y. This was Z, and now I see that this is working, but it's just not at the exact point where I want it to be. So let's figure that out. Why is that happening? This nose and this plane. I have no idea why it's not working. This should be working. Okay. Let's just refresh the project, or this plane is outside the face tracker. This nose is inside the face tracker, and this is outside. Is it outside? Yeah, it's outside. So I can see it's following, but I'm not sure why there's an offset. I'm not sure why this offset is here, because this is the concept and this should be working, and it is working for me here. -1, -1. It's the nose position. Where's the nose position? Okay, let's try to not give any positions, because the transfer, if we are transforming it to the nose of the point, then probably if I don't give this, does that make any difference? Okay, I'm gonna just save it and start a new project, because I'm not sure why this is not working. This should be working, and every time that happens, I this is my go-to idea, just to quit it and restart the project again. Okay, so let's go to a different version than this. I'm gonna go to version 134, just in case if this is a version problem. Um, are you able to see the screen? Okay, cool. So same steps again. I'm gonna go for a face tracker. This is to go into the world space of the, and I'm gonna take something, some object, like a null object into the world space, and this null object is, let's say it's called nose. So this nose, and then I'm gonna take something into the focal plane, and that could be my plane. And we need to follow this plane's position by this nose. So I'm gonna just drag it out here, because this is the position that we're gonna follow, and this is following the face tracker. So that's gonna be converted. And whose global transform that I want, and that position I want to unpack. After unpacking this position, I need to put it to a pack, which is vector 2, vector 3, and the z, I don't want to give it to this. But for z, I need a conversion to the focal distance. Let's say this is my ambient light is giving me the camera distance for now. So this camera distance is, then this is my focal distance, is can be multiplied, sorry, this can be multiplied by this number. Oh, sorry, it has to be divided to divide it to this distance has to be divided so that I can see I can have a difference of z depth, and then it could be multiplied with back to the original position of, and that should be the new position of my plane. This works now. I've changed nothing. Okay, this works now. So I have no idea why is that working there, and it's multiplied by vector 3, where this x is actually opposite of the what I'm doing. Y is in the same frame, so I'm gonna put it to -1 and just put it back. So now you can see that now it's following those positions, and I'm gonna scale it back to zero point 0.2, zero point 0.2, zero point 0.2. Okay. Um, just to recap, where were we? So we took the nose position, applied a global transfer, unpacked it. Global transform is just to know that where are you in the global space, in the world space, and unpacked it so, and we can use it the x and y coordinate, and z we don't want to use. So you can see that in the terms of the z, we are right here. We're not moving at all. Like if I go back, even if I go back, I am not moving. If you just look at my nose, if I go back, my nose is moving, but my projection of that nose onto the focal plane is not moving. So so this is useful when you're making a drawing using your nose. This is useful for when you're trying to collide something with your nose. So pretty useful concepts, these are. And this is the camera distance, the focal distance, that how far is your camera, how far are you from that, how far are you from the focal plane, so that you're going to multiply that factor to original positions, and then just invert the x, and then we get the 3D position like that. um, if I have to convert this to a patch, so all I'm passing it is this the camera distance. So maybe this camera distance could be outside somewhere, and my patch would be this. So I'm going to just group it and call it world to focal plane. And that's how you get the position like that. Okay. There are many things that you can do with this position, by the way. Um you can convert this back to the screen position. You can use SDF. You can draw some things, and yeah, this is the main idea about converting the world position to the focal plane. Sometimes it happens that the new versions are not working. So like the version 139 has like a lot of bugs, but I use it because of the tutorials. But they have to be opened in 139. But we can go back always to the versions which are more stable. And also while using your projects, you can try to so keep a multiple copies of your Spark AR. Like Spark AR, I have. Let me show you my Spark AR version copies. How many I have? So how I do it is I take the Spark ARs like this. So my Spark AR version 27, 29, 30, and I have all those versions all together. So which one I want to use, I can just use it. So when you install the Spark AR, it comes like Spark AR Studio. But if you put this in the end, it saves another copy of it. So every time you open it, you can open it in a different version. Okay, for my project, yeah, Avinash, this is the last lecture, and I'm so sad. Sorry about that. I wish we could have more time and do some more things. I still have like a lot of things to teach, or I don't know, just be in touch maybe, so you can have. For my project, I want to add 3 instructions: one for the front camera and two for instructions for the back camera. All right, how to do it so inspired? I'm not getting the right solution. Okay, can you please tell the solution? Sure, Aman. So quickly, we have very less time. So quickly tell me, what is your first instruction for the front camera? What is your first instruction and when do you want to see it? Same, what is your back camera instruction? What is your second back camera instruction? And when do you want to see it? Quickly just type it in here. I'll just show you here. Okay, so one more thing to notice this one is that, like, what if I don't take this account? Like, there was a very long time I did not really take this into account, this focal distance, because if you don't take this into account, your project still works. But just look at this, okay? It's working, but there's a little bit of um, I don't know if you can notice, there's a little bit of change. Like, it's not rightly at the center of it now, right now. Like, there's a little bit of that z depth change. So uh, yeah, now it's not there. Now it tracks exactly the way it is. So it is very important, this focal distance. And try to work with this, like, if you're converting this. And any other kind of conversion that if you come across, like, if you have any problem, like, then just let me know. So will be switched to the back camera, sorry, in the front camera, instruction will be switched to the back camera. And for the back camera, two instructions are tap to start and tap to change. Okay. So I wanted to ask that, do speakers also have priorities to execute? Like, for layers, it's top to the bottom. No, they don't. You can put a speaker anywhere you want. There's no priorities. There's nothing like as such. But yeah, there's nothing as such. You can put it anywhere you want. The speakers doesn't have the speakers. However, like, if I put a speaker in here, I can put it at, like, wherever I want, and it's gonna act as a speaker. But it doesn't matter, right? Rendering order would not affect the audio rendering, right? Because the visual rendering and the audio rendering is like a different pipelines, I guess. So it's not going to interfere in that. Okay, just to go to the Aman's question, Aman said that he wanted to use the instructions. So to use the instructions, we go to the device, and you will see that this is a custom instruction here. So you can just click on here, and I only have two inputs in here. This is how to enable this and what is my token. All right. First of all, go to the properties, and go to the capabilities, and the capabilities in go to the instructions, and there you have custom instruction, and you can add all the instruction that you want. Instruction number one I want is flip camera. So switch camera, switch. Where is the switch camera? This is switch camera. It's going to be flip camera. And then another I want is, so I'm going to just create a picker UI to remember these. So option picker to remember these, as I won't be able to remember. So I'm just going to copy them here. Where are you? No, I haven't copied it. Okay. So the instruction is flip camera, copy this and paste it. Another I have is tap to start. So I'm going to go to tap to start and tap to change. So tap to start, tap to start. It's going to be like this, tap to start, done. And then another one that I have is edit properties, go to the and tap to change. Tap to change. All right. So the step to change is simply tap to change and copy this. And so I have all the instruction now. I can copy and paste them according to my logic. And my logic says that if I have my, so this is my front camera. If my front camera is enabled, then I need to show just one instructions. Okay. So my instruction will be visible when my front camera is enabled. So I will use an or. I will use an and or with this. That means if my front or back camera is enabled, then show me the instructions. Okay. And now which instruction do I want to show? This is to, like, when to show the instructions, and the tokens are we going to manage now. And also that when my also that I want to show flip camera to this guy if my front camera is enabled. So I'm going to say if then else. If my front camera is enabled, then I'm going to use a text like this, and I'm going to say that show to the flip camera. Okay, but my back camera is enabled by default. If my front camera is not enabled, then my back camera is enabled. So if my back camera is enabled, then I'm going to say that I'm going to use an um, option picker. I can use an if then else as well. I can use an if then else, and I can say that this if then else is a text that gives you a tab to start first, and then it gives you a tab to change. Then when this is true, it's going to show you that, and if it is false, then it's going to give you that. So um, this is going to be true when first of all the back camera is on. When back camera is on, this is going to be true. But this is going to be true all the time. But if the back camera is true, and let's say that when back camera is true, I have a runtime here, and this runtime gets reset. It gets reset, offset, and then offset has a reset in here. Try to pay attention on the small steps, and you will realize that it's nothing but a simple logic problem. So whenever I go to the back camera, it resets the runtime counter. All right, whenever I open the back camera. So when you open the back camera, and after that, if it is greater, if it is less than 5 seconds, then I'm gonna, or maybe 3 seconds, then I'm gonna show the first instruction. Okay, if not, then I'm gonna show the second instruction. So if it is, now if I end with the back camera and I go like this, then it's going to be this condition. So if you see that right now my front camera is on, okay, and if I go to the back camera, it's going to show me tap to start, and then it's going to change to tap to change. And actually also, like, after that, I also want to disable this guy, okay, because I don't want this to be always showing tap to change now. So after this has been shown, I'm going to wait for 3 more seconds. So that means that if I take another uh, less than, which is less than, let's say, 6, and I'm going to end it with this. Don't worry, I'm going to explain you right now, and then if that's okay. So this is tap to start, tap to change. You can see it here, and then it's going to go away. If I go to the front camera, it's going to show me the, oh, okay. So if I go to the front camera, then I also have to take that into account that okay, so if I go to the front camera, then this number should also be reset for this one. So if you go to the front camera, then I probably just have to like make another logic to show this. Like if I by default open the front camera, it's going to show me switch cam, but that's only for 6 seconds. After that, it's going to go away. And if I go to the back camera, it's going to show me both the instructions like tap to start and tap to change, and then it's going to go away. All right, so the I need another refresh bit where, like, if I then go to the back camera, like I can remove this from here. Yeah, I can add another pulse for this. Like if the front camera, um, actually, like, all you need is another logic to, like, it's working now. I think the way you were probably confused about if and then else. So if this helps, I think that should be okay. All you need is an enable, like when the instruction should be enabled, and what is the token, that you want. So that's it. That's pretty much it. That's all you have to do. Aman, is that Aman asked this, right? Aman, is that clear, or still have the? Okay, in the front camera instruction, okay, that we did. Sir, I wanted to ask if yeah, we're done with that, sir. Because when I add a speaker for screen tap, I can hear it in the PC, but it doesn't work in the phone when I use it on the Instagram. Okay, maybe try. I don't know, like, what is the exact problem that You can't use, like, you can't use on Instagram at all, like on recordings as well, because some of the common problems that I see, that when your microphone is enabled, if you disable your microphone, then you can listen to the voice when you like record your videos as well. If that's the problem, that's one thing. Another thing is that maybe your .mp m4a file is not correctly formatted. So let me share that link. Always use this link. I think this is pretty nice conversion link. Varun, can you please share this with the creators? So that link is useful. Like it gives you a proper conversion. So maybe that is the problem. Otherwise, I don't see any problem. Like it may maybe an audio problem, or just like microphone disabled problem. That's it. I have converted it to M4A and channel is mono, but it's still the same. See, if you're able to use it in Spark, that means it is mono and it is converted to the right light. Okay, but sometimes that conversion may not have been done well by these tools. I'm not sure what tool did you use. Can you also let me know what tool did you use for the conversion, so I can tell you like which is that okay? Else you can just reach me out if you still face the problem. I'll let you know the solution. Have done. I think conversion should not be any problem unless you've done things okay. Aman, do you need this patch to be? I mean, like we are actually out of time. Like what I would like to do is that make my instructions so proper, because instructions are very important to give to the user. When you create your filter, when you open your filter, those are the first thing that guide you to what to do in the filter. So you have to be like pretty okay with those visual issues. So with those problems, like you make it intuitive enough that the user understands. When they open the back camera, the first thing that you want to show them is instructions, and okay, like do this and do that. And also it should not be too much. It should be just enough to make them guide about your filter, about your project. Facing the same audio problems. Okay, I'm gonna read a question again if the same problem is for you as well. When you add a speaker for the screen tap, I can hear in the PC, but it doesn't work in the phone when I use it on Instagram. Hmm. Can you send me a test link on my Instagram or here also? I don't mind. Just share a test link. If it is also not working for me, then we'll go inside. No, don't use Format Factory. Use the one that I shared, and that should be the online audio converter. Use this one, and just let me know. Gauri, you can also try using this tool, and you still have the problem. Let me know, because some of the tools are there like not a good conversion, and that creates issues, and we don't want to face any issues. Uh, okay, is there any way to create own instructions? Yes, Harshit, you can create your own instructions by creating like a 2D text, like a 2D text, and then you can put your instruction name here, like, hey, uh, Harshit is my name in this life. So whatever makes sense to you, you can use these instructions. Even sometimes these instructions are better because they give you like flexibility to make them opaque, like fade in, fade out, like this. And you can use this instructions anytime, any way you want. Um, yeah. Another thing is online audio converter is the same. Okay, Gauri, you can send me the test link and I can have a look. There's no way that the tool is bad or something. Probably something are missing. We'll figure it out. Okay. If this is the audio, if this is try to figure out by yourself first, like try to figure out like if any other audio is working, if any other project audio is working, so where is the issue. Then if you figure out where's the issue, then I will be able to help. If you come with a vast problem, then I'll be just giving my time to just to figure out like where's the problem. And the solution of course I can give you, but it's better that we can first find out the root cause of the problem, and then we can fix it, right? Okay. Is there any way to connect two audio into single speaker? Why not? Who's stopping you? Why not? I think try to search on the documentation. You can combine two audios into one speaker, or into one speaker. You mean? Yeah, I think the couple of new patches can combine that. Now, um, gives an audio and combining two audios. No, and sorry, I'm so sorry. That doesn't make sense. That doesn't make sense combining two audios to one speaker. Instead, you can use two speakers. What's like use two speakers independently. It's mixing, right? It's mixing already. So that doesn't make sense to have same audio mixed to the same speaker. But maybe possible, maybe not. I'm not really sure. But it doesn't make sense to me. I think if there are, let's say, two different audios, we can use two different speakers and play them together. That's the same thing, right? Shekhar, that I think he's asking differently. He's asking how to combine two audios, maybe like it's audio one and audio two, and to play them together with the one speaker, rather like going to a different audio and then one by one. That could be possible as well using UI Picker. Yeah, you're welcome, Chintan. I'm so happy. I'm so happy that we could do this, and thank you so much, everyone, for being a part of this great journey. Like it takes a lot to sit for 2 hours and study, and then even working on assignments, and especially when you're learning something new. So this is a great job by everybody, like everyone and everybody, reskill team as well. So I think I enjoyed the entire process thoroughly, and yeah, I hope we can still be in touch and keep giving knowledge transfers. If you learn something new, teach me as well, and if I learn something new, I'm happy to share. We're still connected on the community, and this is so good to hear, Aman. This is so good to hear. I'm super happy to hear this. I'm glad that you were able to learn. I'm glad that you're able to make a lot of things now. And yeah, get those instruction fixed, and you're good to go. Good to go. And yeah, I'm super happy. Thank you, Sandesh. It's been a great journey as well, and for sure, I'm here if you have any questions. And thanks, Praveen. Thank you, Kostaba. Thank you, Harsh. Thanks, Ashwini. Wow, I can't believe this is the last lecture, but thanks, Irfan. Thank you to being here, and yeah, thanks, Avinash. All right, Varun. I think this is the closing of our session, and yeah, over to you now. Hey, Propane. Thank you. Ah, you called me Sensei. Okay. Thank you.
Yeah, actually, I was sitting at the backstage only, but I was not interrupting in between because there was a very fascinating interaction between the audience and the mentor regarding this AR session, and it was indeed a very successful and insightful learning series for all the sessions. And I, as a part of Team Reskill, thank you very much, Naveen, sir, for taking out your time on the weekends and coming here and contributing to the community, folks. Like we have some wonderful reviews from many of the persons. You have developed the interest in Spark AR Studio for the students, and you know the interest in a subject is only and only because of a subject teacher who is teaching that. So we heartily thank you for your efforts. And yeah, guys, you can surely stay in touch with Sir. Whatever you are making it, you can just post it on our Reskill X Sparky, our Facebook group. You can search it and you'll find it easily. I have shared the links as well, so you can post it down there. Mentor will also be happy that yes, students are learning and creating something new, and we will surely come up with many more opportunity regarding this. So please stay in touch through our LinkedIn, Twitter, Instagram, or any of the handles. So no issues regarding that. And I have shared the attendance link for this final session as well. You all can fill that attendance form. It is available in the live chat. So with the thank you note, I would like to wrap up with this series and this session. Thank you everyone for staying with us and learning with us. We hope best for you all. And thank you Naveen sir once again for joining us and doing great stuff. Thank you.
Thank you so much for being a part of this, and all the best in your journey. Be stay in touch. I want to see you grow. I want to see you creating a lot of stuff because this AR industry is booming right now, and I will be so much happy to see your works everywhere. And share your work with me, and I'll be happy to have a look and give some suggestions if I can. And let's stay in touch. All right.
And of course, that was a great point you evangelized, sir. I would like to request all the audience here that you guys can please come up with some kind of LinkedIn post or Facebook post where you can tag Naveen sir and Reskill team, so that we can stay in touch and we can get to know that you have created something new from these learnings. So you can take the screenshot of this video where sir is teaching something, and then you can post it or some sort of real augmented reality filter, and then we can surely reward you as well for some fascinating filters and all those stuff. And Naveen sir will also get a boost that yes, these
Yeah, I want to
15
take a
days of
screenshot.
AR was
I want to take a
these
screenshot.
15 days of AR were really
Okay.
amazing.
Can you remove this attendance
Yeah, just
link
give me a second.
subtitle? Yeah.
Just give me a second. I think
Yeah.
now
I'm
it's
going to
great.
take a screenshot. All right. Done.
So yeah, thank you very much. Let's wrap up with this session. Thank you everyone. Have a good day ahead.